Hi, this is Jack. This will be a tutorial for EC571 as well as EC580 to use the Cadence Virtuoso software to do schematic and the layout of a simple CMOS inverter. And right now we're going to do the schematic. So once you open up Cadence, collect files, new, library, we're going to create a library. For example, EC571. You can just call it EC571 or 580. I'm gonna call it test 3 because test 1, 2 are used. And it asks for the ASIC technology file, ASCII technology file. We're gonna browse to AD, ENG, OPT, IBM CMOS, IBM PDK, by CMOS HHP, this one, and CDS setup, no, actually CDS lib, by CMOS HHP. Scroll down to the bottom, show all files, choose, OK. Loaded successfully. Close. Click the IBM PDK. Add IBM PDK to Properties. Select by CMOS 8HP. Select number of levels of metals M7. Okay. So now we've created a library, and we're gonna work in this library. First, we're gonna create a cell view. What do I call it? Inverter. Keep the view as schematic, type of schematic, and application open with schematics L. So OK. If you have license problem, always say always. And this will open up the schematic here. And let's go ahead and draw a CMOS inverter. So we're gonna have the PMOS and NMOS. So PMOS and NMOS are chosen from the by CMOS 8HP library. Click it and search for PMOS. PMOS is called PFET. Select symbol. And here you can actually edit its size. So we're gonna keep the length at its minimum length, 120 nanometers. We're gonna keep the width at 2 micron, and we're gonna give it a number of fingers of 2, actually 4. So each finger has 500 nano. And hide it. Click to drop it, and click F to fit it to screen. Then we're gonna add the NMOS. We can change this to N. Press Tab. And this will update to NMOS. We're gonna keep the length still the same to minimum, and the width to 1 micron, fingers to 2, so that it has a ratio of 2 to 1, the width of the PMOS over NMOS. And drop it here. We're also gonna have substrate contact, sub C. Change this to sub C. And we're gonna rotate it such that it faces this way, because this is a substrate. And we're gonna connect all this together. So make a connection here. Connect here. This is how you connect a NMOS to the substrate. And for the PMOS, the substrate will always tie to VDD, which will be here. But we're not gonna import and put the VDD ground here, because we're gonna create a symbol. This is create pin, and we're gonna click that. For the input, we're gonna say in, keep the direction as input, hide it. So this is the pin. Say out, direction output, hide it, put it here. For VDD, you can say input output. For ground, okay, I'm gonna save this. So this has 4 terminals, 4 nodes, or if you will, and we're gonna package this into a symbol. So a symbol is like a black box, and we can only see these 4 nodes outside the black box, and we cannot see what's inside unless we descend edit into this. I'll show it later, and this will provide a more clean look of our circuit. So to package this into a symbol, we're gonna go to create cell view from cell view, and OK. So the ground should be in the bottom pins. Click OK. This is the symbol view, and this is the default that it gives us, but we're not gonna need many of those names, so let's go ahead and delete this. And for the inverter, a symbol of the inverter is a triangle with a bubble on the front. So why don't we draw a triangle here? But first, let's move this pin names near the wire, besides the wire, and draw a triangle here. It don't have to be really big. Just make this big is enough. So let's put the output, make it closer. Move this here. Move this here. Okay, save that. So this is our symbol, and what you should keep in mind is that the shape of this symbol here is a triangle with a bubble. Doesn't matter. What matters is this 4 nodes, and these 4 nodes will be connected to ground, VDD, and input is to VPOS, output to a load capacitor. So the symbol is really just for demonstration purpose, and when we import the symbol into another cell view, when we look at the symbol, we know that this is the inverter, because this is the shape of the inverter. This is what you typically draw, and it doesn't matter. It really doesn't matter what shape you draw here, but it makes sense to draw an inverter for an inverter. And once we check and save it, we're gonna close that. We're gonna close this schematic tool, and let's go to Library Manager. Select the library. We're gonna create another cell view. Why don't we call it inverter test? And OK. Okay, let's put the symbol inside the schematic. And it will be in the library created here. We have a symbol view, right? And let's put it here. And we're going to add a input, which is VPOS. And here's the VPOS properties. So we want to give it ups and downs, ones and zeros, so a pulse wave, so square wave. And what do we say? Voltage 1 is 1.5 volts, voltage 2 is 0. It has a period of 4 nanoseconds and a width of 2 nanoseconds. So that's 50% duty cycle, right? And for the delay, rise, and fall time, we're going to leave it blank, so the cadence will give its default value. If I remember correctly, the rise and fall time will be 10 nanoseconds for the input. I'm sorry, 10 picoseconds. And hide it. put it here. Also, we need a ground. And we're gonna need a voltage source that's at 1.5 volts, which is the voltage for the CMOS of 8 HP. And let's go ahead and connect those. So connect here. Connect VDD to this voltage source, to ground, to ground. And also for the output, we're going to have a load capacitor, let's say cap, and 1 pico. This is too much. Let's give it a 1 farad. So farad is 10 to the minus 15. And put it here. Connect it. One works. Okay, this is too close. So, okay, this is a very common arrows. So this is the symbol we draw, and it occupies the area of this big. And we can't put our components too close to it, so it overlaps. Let's move this here. Delete the wire and reconnect it to this one to ground. Check and save. Okay. Now we finish the more like a test bench of the inverter. So this is an inverter, and what's inside this? If you click on it and press the Shift and E, it's called Descent Edit. It will show us the symbol of internal view. Control and E, go back. Launch ADL. Always. Select the transient simulation. Give it a stop time of say 20 nanoseconds. And choose conservative. Outputs. So for the outputs, we're gonna first label the nets. Create wire names. Say in space out. Create 2 wire names. Hide. The first one I'm gonna put it here. So this is the input wire. This is the output wire. These 2 nets are the 2 nets we're gonna plot. So to plot outputs, select outputs. To be plotted, select on schematic. Click here. Click here. And it will show up here, right? So be sure this is checked. Plot. Wait for a while, and it will graph the input and output of our inverter. Okay. So this window is what the simulation tools does in the background. There are some useful information. For example, you can set the circuit. Eventually, we have 4 nodes. This 4. We have 2 BSIM4. I think this is a standard protocol for the MOSFET. And so we have 2 of them, which is the PMOS and NMOS. We have 1 capacitor. We have 2 voltage source. This one, and we have 1 resistors. But we didn't put any resistors. And what's the resistors? It turns out that it's the substrate that is modeled as a resistors of 1.5K approximately. So, and if we look at the simulation graph, this one. If we click here to strip it, and this more easier to see. You don't have to do this, but in order for you to see it easy. So this is the input, zeros, ones, and this is the output, 1 0 1 0, right? So this is the behavior of the inverter. And if we zoom in, we can see that from here to here, it actually takes some time for the inputs to go from 1 to 0, or 1.5 volts to 0 volts. And this is about, if we mark this, about 0.02 nanoseconds, which is 20 picoseconds, right? And for the inverter, correspondingly, it's gonna take a longer time to reach this 1.5 volts. About here. So this is about 160 seconds. And if we make this capacitor a little bit smaller, so right now it's 10 farad, we're going to make it like 2 farad. Here and mark about here. So see, this is 0.058, which is 58 picoseconds, and take less time. Why is that? Because I changed the capacitor smaller. Before it was 10 farad, now it's 2 farad. So the smaller capacitors value, the less time it will take to charge and discharge itself. So therefore, the less time it will take to charge V1 VDD or 1.5 volts, and to discharge. If you want to save this graph, click File, Save as Image. Select a path you want to save to, and change the name. It's saved. The default is PNG. And if you want to print this out, it's recommended you use the white background. And I think that's it. This is the schematic tutorial of a simple CMOS inverter using Cadence Virtuoso and IBM H200 technology and PDK. Thanks.